There's a good chance a square of chocolate melted on your tongue this week, smooth, glossy, snapping cleanly when you broke it. But that bar began as a bitter seed buried in slimy white pulp, inside a football-shaped pod hanging off a tropical tree. Between that seed and the sweetness in your mouth is one of the strangest, most patient journeys any food takes. So how is chocolate actually made? It all starts with a tree called Theobroma cacao. The name literally means food of the gods. It only grows in a hot, humid band near the equator, and its fruit is bizarre. Instead of dangling from branches like apples, the pods sprout straight out of the trunk. Crack one open, and you don't find anything brown or sweet. You find 30 to 40 pale seeds, packed in neat rows and wrapped in a soft white pulp. Those seeds are the raw material of all chocolate. And here's the humbling part. A single cacao tree produces only about 20 to 30 pods in a whole year. That's barely a couple of pounds of finished chocolate per tree per year. Bite into a raw bean straight from the pod, and you'd spit it out. It's bitter, astringent, and tastes nothing like the bar in your hand. Everything that makes chocolate chocolate still has to be built out of that seed. So who figured this out? The people of Mesoamerica, the Maya and later the Aztecs, got there first, more than 1,000 years ago. But they didn't eat chocolate, they drank it. They ground roasted cacao into a bitter, spiced, water-based drink the Aztecs called chocolatl. No sugar, no milk, just intense, foamy, bitter cacao. The beans were so prized they were used as actual money. When cacao reached Europe, people sweetened the drink. But for centuries, chocolate stayed a beverage. The leap to a solid bar took 3 19th century breakthroughs. First, in 1828, a Dutch chemist named Conrad van Houten patented a hydraulic press that squeezed much of the fat, cocoa butter, out of the ground beans, leaving a dry cake he could mill into cocoa powder. Then in 1847, the British firm Fry & Sons mixed cocoa powder, sugar, and melted cocoa butter back together into a paste you could pour into a mold, the first true eating bar. And in the 1870s, a Swiss maker named Daniel Peter added powdered milk, borrowing techniques from his neighbor Henri Nestlé, and invented milk chocolate. The bar as we know it was born. Now let's walk the actual production line, from pod to bar, in order. Step 1 happens right on the farm, fermentation. The wet beans and their pulp are heaped into boxes or piled under banana leaves and left for roughly 4 to 7 days. Step 2, the beans are spread out to dry in the sun for days until they're stable enough to ship. Step 3, at the factory, they're roasted. Step 4 is winnowing. The roasted beans are cracked and bursts of air blow away the light, papery shells, leaving the pure inner meat, the cocoa nibs. Step 5, those nibs are ground. As the grinding heats them, their fat melts, and the solid nibs turn into a thick, flowing liquid called chocolate liquor or cocoa mass. No alcohol involved, despite the name. Step 6, this mass is blended with sugar, extra cocoa butter, and milk powder if it's milk chocolate. Step 7, the mixture is refined between steel rollers to crush the particles fine. Step 8 is caneening, hours of continuous kneading and churning. And finally, step 9, tempering and molding, where the liquid chocolate is carefully cooled, poured into molds, and set into the glossy bars you unwrap. That's the recipe. But why does each step actually work? This is where chocolate gets genuinely clever. Take fermentation. It looks like nothing's happening, but inside that pile, a microscopic riot is underway. Yeasts and bacteria feast on the sugary pulp, and the whole mass becomes strongly exothermic. It heats itself up to around 45 to 50 degrees Celsius. That heat kills the seed's embryo, which stops it from sprouting and unlocks a cascade of enzyme reactions inside the bean. Those reactions create the flavor precursors, the raw chemical ingredients of chocolate taste. This is the single most important step in the entire process. Fermentation is credited with determining roughly 2/3 of the finished chocolate's flavor before it ever reaches a roaster. Skip it, and you can't fix it later. Roasting then takes those precursors and cooks them. At around 120 to 150 degrees Celsius, For 15 to 45 minutes, the Maillard reaction, the same browning chemistry that flavors seared steak and toasted bread, transforms the precursors into hundreds of aromatic compounds. That's when the bean finally smells like chocolate. Then there's refining, and this one is pure physics. Your tongue can detect grittiness in any particle bigger than about 30 microns, 30 thousandths of a millimeter. So refiners crush the sugar and cocoa solids down to roughly 15 to 25 microns, below that threshold, which is exactly why quality chocolate feels smooth instead of sandy. And that's before the two steps that separate ordinary chocolate from great chocolate. Conching, invented by Rodolphe Lindt and Bern in 1879, is that long, patient churning. Lindt's own company tells a legend that a mixing machine was left running by accident over a weekend, and the chocolate that came out was transformed, smoother and more aromatic than anything before. Whether or not that's literally true, the effect is real. Hours of kneading drive off harsh, acidic compounds left over from fermentation and coat every particle in cocoa butter, turning a rough paste into something that flows like silk. The final piece of science is the most elegant of all. Tempering. Cocoa butter is what chemists call polymorphic. It can crystallize into 6 different forms, and only one of them, called Form V, is the good one. Form V crystals melt at about 34 degrees Celsius, just below body temperature. That single fact is why a good bar is solid and snappy in your hand, but melts the instant it hits your tongue. Tempering is the controlled heating and cooling that coaxes the cocoa butter to set almost entirely into Form Phi, giving chocolate its shine, its clean snap, and that melt. Now scale it up, because the numbers are staggering. The world grows nearly 6 million tons of cocoa beans every single year, and almost 2/3 of it comes from one region, West Africa. The Ivory Coast alone produces around 38% of the global supply, about 2.2 million metric tons in a recent year, with neighboring Ghana adding roughly another 19%. So close to 60 cents of every dollar of the world's cocoa traces back to just 2 countries. And remember, each tree yields only a couple of pounds a year, so that 6 million tons represents billions of trees, and pods that are still, to this day, cut down and split open largely by hand. The machinery reveals how far we've come. Lindt's original conche used a heavy granite roller grinding back and forth in a trough, and it could take more than a full day just to process a single ton of chocolate. A modern rotary conche can churn through 3 to 10 tons in under 12 hours. With volume that big, controlling quality becomes an obsession, and the number one thing plants measure is particle size. Remember that 30 micron threshold? Below it, the tongue is so sensitive that a difference of just 2 or 3 microns is detectable, so factories constantly sample and measure their chocolate's particle size to guarantee a smooth mouthfeel. They also watch for defects, and the most common is fat bloom, those dull, gray, powdery streaks on old chocolate. That's not mold or spoilage. It's the cocoa butter slowly abandoning that carefully made Form 5 and creeping toward the more stable Form 6, pushing fat to the surface. There's also sugar bloom, where surface moisture dissolves the sugar and it recrystallizes into a rough film. Both are why chocolate is stored cool, dry, and sealed to protect all that crystallization work. So think back to that square melting on your tongue. It's the end of a chain that started with a bitter seed a tree could only make a handful of, that had to rot in its own pulp to build flavor, get browned like toast, ground to a liquid, crushed finer than your tongue can feel, churned for hours, and then crystallized into one exact molecular form out of 6. The snap, the shine, the melt, none of it is an accident. Every bit of it was engineered, step by step, out of something you couldn't have eaten. That's not just candy. That's one of the most sophisticated transformations in your kitchen.